In this video, we will discuss about exercise 1.2. This exercise is based on irrational number in which we want to prove irrational number. First, I want to explain what about the irrational number and rational number. In the introduction class, we discussed rational numbers are expressed in the form of P upon Q. What? Rational numbers are expressed in the form of P upon Q, where P and Q are integers and Q should not be equal to 0. Like 1 upon 2, 3 by 2, 7 by 2. These all are what? Rational numbers. Another way we can say all integers are rational numbers. And we can also say terminating decimal expansions are, means what? If we divide 1 by 2, we are getting 0.5. This one is called terminating decimal expansion. And non-terminating, if remainder is not equal to 0, remainder will never 0, then that is called what? Non-terminating. Non-terminating repeating, after point we are getting repeating block, then that type of the numbers are also called what? Rational numbers. Now only one condition is remaining, if numbers are non-terminating, non-repeating, and that sort of the numbers are called irrational number. And irrational number are what? Root 2, root 3, root 5. Prime numbers root. Prime numbers are what? 2, 3, 5, 7, 11, 13, 17, 19. These all are what? Prime numbers. And prime numbers square root will be what? Irrational number. And why they are the irrational number? Because once we solve root 2, we are getting 1.414 and so on. After point we are getting different values up to infinity. So we are getting this one non-terminating, non-repeating. So in this exercise, in the exercise 1.2, we want to prove irrational number. In the 9th standard, we studied representation of the what? Representation of the irrational number on the number line. So in this class, in your standard, we will discuss how to prove irrational numbers. So there are, in this exercise, we are having 3 questions. And question number 1 is what? Prove that root 5 is irrational. For understanding of this question, first I am solving some examples of this exercise. Then we are getting some idea, and then I will discuss about question number 1. So, in which I am having one example, and that is what? Similar example. I will discuss this question number 1. But solving this question, first I am taking one example. And what is the example? Prove that root 2 is irrational. Once we know this example well, then automatically we can solve this one. So this process is important. So in which we are having 3 questions. We want to prove root 2, square root of 2, square root of the 3, and third one square root of 5. In this class, I am going to take these all questions. So learn carefully, observe carefully, 100% you will get some idea about these sort of the questions. So I am taking this example first, then I will discuss square root of 3, and then I will take this one. So this process will be followed in the all questions. If there is another one, if you are having prime number 7, root 11, root 13, again we will use this same process and we can prove irrational numbers. So now I am going to start to discuss this question. What is the question? Prove that square root of 2 is irrational number. Already we know root 2 is the example of irrational number. Why this one is the example? Because once we solve what? Root 2 equal to, once we solve square root, then we are getting what? Root 2 is 1.414 and so on. After point we are getting different numbers up to infinity. So it is non-terminating, non-repeating. Non-terminating means remainder will never 0, and non-repeating, after point we are getting different digits not repeating below. So this one is the irrational. We know well root 2 is the irrational, but we want to prove what? We want to prove this one, why this one is the irrational. So for prove this one, we are having a standard process. First, assume root 2. This is the irrational, everyone know well, but I am assuming, what I am doing there? I am assuming root 2 is rational. It is not rational, it is irrational, everyone know well, but we are assuming there this one is rational. So let root 2 is rational. We are assuming. If we are assuming this one is a rational, so rational definition is showing what? Ratio, fraction form. So rational number is what? P upon Q. Now I am taking A upon B there, where AB is what? Integers. So first I am assuming root 2 is rational. It is not rational, it is irrational. But why I am doing this one? We want to prove this one. So first I am assuming this is the rational. Then rational, so this number, this irrational number, root 2 should be equal to A upon B. So I am taking A upon B. AB are integers, but in this question I am taking AB are coprime. And what about the coprime? What I am taking, I want to prove this one, so I am taking AB as a coprime. And coprime numbers are what? Those numbers which are having HCF equal to 1. We already discussed HCF. So if two numbers are having HCF equal to 1, then we can say both numbers are coprime. Like examples of coprimes are 2, 3, 2, 3. 2 and 3 both are prime numbers. So once we do factors, what about the factors of 2? 2 can be written as 1 into 2, yes or no? And 3 can be written as 1 into 3, prime numbers. And both numbers are having, what will be the HCF? 2 and 3 are the factors. There is no common. If no common, then what will be the common? 1. 1 is there common. So HCF of 2 and 3 is what? 1. So what we can say? 2 and 3 are coprime number. So coprime numbers are having HCF equal to 1. So what we are doing? Let root 2 is irrational. We are assuming first. So we are assuming, so this root 2 can be written as A upon B, and where AB are coprime. In the next line, what are we are doing? Squaring, square both sides, squaring both sides. We are, this is the equation, we are in left side and right side, so we will square both sides. So once we do square, we are getting this one. Now we know well root 2 square will be what? 2. How this one getting? Root 2 can be written as 2 power 1 by t and its whole power. Now we will apply laws of exponent. A power m whole power n, then we can written as 2 power 1 by 2 into 2, and answer will be 2 power 2 by 2, and this is 2. So in this way we are getting this one. Now a square, a upon b whole square will be what? Square of the numerator and square of the denominator. We can write like this. Now doing cross multiplication, we will multiply 2 to this one, and there is nothing but 1, so we are multiplying by this one, we are getting this one, and put equation number 1, and this can be written as, this will be divided to this number, so b square equal to a square by 2. Now from this equation, what we can say? 2 divides a square. 2 is dividing a square, so what we can say? 2 divides a, if 2 divides prime number, 2 is the prime number, and it is dividing this numerator a square, square numbers, integers square, a is the integer, integers square, it is dividing, so automatically 2 divides a, 2 will divides a. This is the one theorem. If prime number divides integers square, then that prime number divides that integer. Clear? This is the one theorem, so this is applying there. It means A is having what? One factor 2. A square is dividing by 2. A divide 2 divides A. It means A is having, A is the coprime. A is coprime, and from this equation what we can say? A is having factor. A is having factor. So there is a problem. We will discuss next after its conclusion. Now I am going to next step. What we will be do? First, assume this one, write this one way, square, solve this one, and conclude this one. Now I proved that A is having one factor, but we are having A and B. So I want to prove O of what? B. What about B? So for proving B, I am taking A equal to 2C. I am putting A equal to 2C in this equation. In the equation number 1, I am putting A equal to 2C, where C is an integer. So once we put and solving, putting A is what? 2C. 2C whole square. Whole square will be 4C square. Then solving this one, 2 will be going to downward in the denominator. B square equal to 4 by 2, 2C square. 4 by 2, C square. So B square equal to will be what? 2 1 ja 2, 2 2 ja 2. How many times it is going? 1 time, 2 time, 2C square. So this can be written as C square equal to this going to be denominator. C square equal to B square by 2. So from this equation what we can say? 2 divides B square. What is happening there? 2 prime number is dividing this one. So automatically we can say this 2 will divide B also. It means B is also having one common factor. B is having factor. 2 divides A means A is having factor, and from this equation we are showing what? B is also having factor. It means how A and B are coprime. If A and B are having common factor, A and B are having from equation 1 and 2, what we are observing? Both equation, from equation 1 and 2, we are observing that A and B both are having common factor. Both numbers are dividing by 2. So if they are having dividing by 2, then how A and B are coprime? So there is a contradiction. There is a contradiction. So what we are writing? From equation 1 and 2, 2 is a common factor. In both equations we are getting 2 is a common factor of A and B. This contradicts that A and B are this contradict. There is a contradiction that A and B are coprime, no common factor. किसको कॉन्ट्रडिक्ट कर रहे हैं? ये ए बी आर कोप्राइम. ए बी क्या था हमारा? कोप्राइम है. इसको यहां पर इसका कॉन्ट्रडिक्शन हो चुका है. सो आवर अजम्पशन इज रॉन्ग. सो हमने जो एज्यूम किया था रेशनल, वो रॉन्ग एज्यूम किया है. रॉन्ग नंबर को हमने एज्यूम कर लिया है. कॉन्ट्रडिक्शन पैदा हो गई है कि दोनों ए एंड बी जो हमने कोप्राइम लिए थे उनके कॉमन फैक्टर्स आ रहे हैं. बोथ नंबर्स आर डिवाइडिंग बाय 2. सो हाउ दे आर coprime? So we are having there is a contradict. So our assumption is wrong. Therefore root 2 is an irrational number. So what we can say? Root 2 is an irrational number. Observe again what is happening there. We want to prove root 2 is irrational. We know well. What we know? We know that root 2 is a what? Root 2 is a irrational, but to prove this one we are assuming this one. So we are assuming rational, so we will put A upon B. A B are coprime. हम यहाँ पर A B को coprime ले रहे हैं, और coprime का मतलब उनका HCF1 होना चाहिए. दो नंबर्स अगर coprime होंगे तो उनमें कोई भी कॉमन फैक्टर नहीं होना चाहिए. कोई भी कॉमन फैक्टर नहीं होना चाहिए. अगर कॉमन फैक्टर आ गया तो वो कोप्राइम नहीं होगा. तो इस चीज को हमें यहाँ पे प्रूव करना है. तो हमने दोनों तरफ स्क्वायर किया, हमारे पास एक इक्वेशन आती है. इस इक्वेशन से हमने ऑब्जर्व कर लिया कि जो हमारा 2 जो है वो a स्क्वायर को डिवाइड कर रहा है। इट मीन्स इस एक थ्योरम होती है जिससे हम कह सकते हैं कि अगर इफ 2 इज डिवाइड्स a स्क्वायर सो 2 ऑटोमेटिकली डिवाइड्स a। इट मीन्स a is divisible by 2, so there is a factor, there is a factor, then not possible to co-prime, but there is another number is also there b, so we want to prove this one, so we are assuming or putting a equal to 2c and c is a integer. In this equation we are putting, solving, again we are getting 2 divides b also. It means a and b both are having factor, so a and b cannot be co-prime. So our assumption, whatever we assumed there, is wrong assumption. So finally we can say root 2 is not rational. Root 2 is not rational. It is irrational. I hope you are getting this topic and this question and understanding this one well. So on the basis of this question, we will do next 2 irrational number, root 3, square root of 3 and square root of 5. Observe. Now after this question I am taking what question? Square root of, after this question I am taking what question? Prove that root of 3 is irrational. After this one we discussed what? Prove that root of 2 is irrational. Now I am taking next example, prove that square root of 3 is irrational. Same process we will follow in this question. Again what we will do? First we assume this irrational number to rational number. Let square root of 3 is rational. We are assuming rational, so what will be happen? We will put this one equal to a upon b, and where a and b are what? Co-prime. Clear? And square both sides. Now we are going to square this one. It means once we square this one, what will be happen? We are squaring. It means square means half, power half. So this will be converted to like this, and we are getting 3. So square root of 3 will, whole square will be what? 3. Clear? Now a square upon b square as it is. Now we are doing what? Where there is will be 3b square. Then there will be what? 3. From equation 1, what we can say? 3 divides a square. So 3 divides a. From the theorem we are saying 3 divides, this number is dividing a square, so 3 will also divide a. Yes or no? It means there is also a common factor. A is having one more factor. It is not a co-prime. So but we want to prove b also, so put a equal to 3c, not 2c, 3c we will put in the equation number 1. Then what will be happen? C is a integer. What we are putting? There is a 3 and there is a 3. So there is 3. There is 3 square will be 9. 3 square will be 9. 9c square. Now solve this one. How we will solve this one? Observe. 9 divided of 3. 9 divided of 3. What we are getting? It is going 1 time. It is going 3 times. So result will be what? 3c square. So what we can say? B square is also divisible by 3. It means 3 is divisible by b. 3 divides. So what we can say? 3 divides b square. So 3 also divides b. So from equation 1 and 2, 3 is a common factor of a and b. This contradicts that a and b are co-prime. These equations 1 and 2 are going to contradict what we assumed. So this contradicts that a and b are co-prime. So our assumption is wrong. Therefore root 3 is an irrational number. And in this way we proved that what? Root 3 is irrational. So this is a similar process. So now I am taking question number 1 of exercise 1.2. And that one is what? Prove that root 5 is irrational. Same process we will be follow there. Again, what I am going to change in this question, observe this one carefully. Prove that root 3 is irrational. What we want to prove? We proved this one. Now I am taking question number 1. What? I am taking question number 1. I am taking question number 1. We want to prove what? Square root of 5. We want to prove that square root of 5 is irrational. How we will prove? I am going to replace 3 to 5. 3 की जगह हम 5 replace करेंगे only. Let this one is rational. So it is rational. So this will be what? Root 5 will be a upon b. We will square both sides. Then what we are getting? We are getting like this. Just do the square. This will be what? Now once we put 5 there, then it's square root of 5, its whole square will be what? Like this. This will be 5. So we are getting 5. Clear? Now then there will be 5. There will be 5. Now from this equation what we can say? 5 divides a square. So 5 also divides a. Now for b, what we will be do? We will put a equal to 5c. A equal to 5c in equation 1. Where is equation 1? This. That place we will put a equal to 5c. In the root 3 we will put a equal to 3c. In a root 2 we will put a equal to 2c. Similar process we will follow. Where c is an integer. Now we will use 5 there. We will use 5 there. We will use 5 there. But 5 square will be what? 5 2 ja 25. 5 2 ja 25. Now solve this equation. We are getting 25 by 5. How many times it is going? 1 time, 5 times. So there will be what? 5. So there we are having 5. So what we can say? 5 divides b square. So 5 also divides b. From the theorem we can say 5 divides b square. It means 5 divides b. This is a one theorem. If prime number divides integer square, what is the theorem? Observe. If p, one theorem is there, p is the prime number divides integers square. Integers square, if prime number is dividing, then this prime number will divide this integer. This is the one theorem, and by using the theorem we are saying what? A and B are having common factor. So from this and this, from equation 1 and equation 2, what we can say? 5 is a common factor of 5 is a common factor of A and B. This contradicts that our assumption. These factors are contradicting what we assumed rational. So both are having factors. A and B should not be having factors, but they are having factors. So due to this contradiction, there is a problem. So we are saying, so our assumption is wrong, and therefore root 3 is an irrational number. Not root 3. What? Root 5. By this contradiction we can say 5 is a common factor of A and B. This contradicts that A and B are coprime. What? A and B are coprimes. So our assumption is wrong. So what we can say? Root 5 is an irrational. It is not rational. So in this way we proved that. By this process, what we are doing? We proved square root of 2, square root of 3 and square root of 5. 3 questions are based on in this process. By using one process well, once we understand one process well, we can solve other questions. Now, in the first question, we are having single irrational number. single irrational number like root 2, root 3, root 5. But in the question number 2 and question number 3 of your exercise, having sum of two numbers and division and multiplication of the two numbers, and in the two numbers they are having rational and irrational. One is rational, another one is the irrational. Now in this question we are having addition of the one rational and this one is irrational. Now in this we are having division of one rational and this one is irrational. This one is the product of one rational number and this one is the irrational number. Now in which we are having addition of, this is similar to this one, addition of this one and this one. And there one example is there in which we are subtraction of one rational and one irrational number. So how we will solve these types of the question? So for solving these types of the question, I am having one example there. So that 5 minus root 3 is an irrational. We want to show this one is the irrational. So there is a one standard process. If you follow this process, you will gain something and you can easily to prove these sort of the questions. Now there is also a standard process. What is this one? First, this is the irrational. Question is saying it is a confirmed that is the irrational. Why 5 is the rational and 1 irrational? We already know operations of the real number. One rational and one irrational, addition and subtraction will what? Irrational. But we want to prove, so we will take this number as a rational. What we will take? Rational. Then what we will do? We will take rational, then rational, so we will use a upon b. Rational numbers can be written as p upon q. I am using a and b as integers, so where a upon b is the rational number and where a and b are what? Integers. In the introduction class, I already discussed integers, rational numbers, irrational numbers, real numbers. So you can observe from that class. Now 5 minus root 3 equal to a upon b. Then what we will be do? Now in the next step, we will separate rational and irrational number. By observing this equation, we are observing 5 is the rational, a upon b is the rational, but this one is the irrational. So we will separate. One side we should take what? Only rational. So this one is the rational. So I am transposing this number to the left side. Then what we are getting? Sign will be changed. 5 minus a upon b. And bring this irrational number to the right side. So by observing this equation, once we take LCM, then we are getting like this. Taking LCM b. So we will, after solving, we are getting this one. Now observing this equation, we are observing that what? Left hand side of this equation is rational. Left hand side of this equation is rational and root 3 is the irrational. So how one equation left hand side is rational and other side is irrational? How is it possible? It means this equation is not correct. It means our assumption is wrong. So what we will say? From equation 1, left hand side is rational and right hand side is irrational. So our assumption is wrong. Therefore 5 minus root 5 is not rational. It is irrational and it is proved. So these types of the questions are so simple. Assume as a rational and separate the equation. One side take rational and other side take irrational. If left hand and right hand is not equal, so we are concluding what? That equation is not correct. So we can say what? Given number is not rational. What we assumed, our assumption will be wrong. And we can say given number will be what? Rational number. Now I am going to do question number 2 and 3, and all questions in these questions we are having same pattern we will do. Now how we will solve? Observe only, you will gain something. So solving this question, I given you a standard process. You will follow that process, then you can get answer. Now I am taking, first I am taking, so that 5 minus root 3 is irrational. So I am taking another one number. On the place of this question, I am taking this question. Question number third. What question I am taking? Question number third. Third one. Question number third one I am taking there. So that 6 plus root 2. 6 plus root 2. What we want? I am doing one question there. What is the question? Question number 3 of your exercise. Question number 3. Prove that the following are irrational. And first I am taking prove that the following are irrational. Third one, 6 plus root 2. I want to prove this one. So first similar process we will follow. Let 6 minus, not minus, 6 plus root of 2. 6 plus root of 2. 6 plus root of 2 is rational. First I am assuming this irrational number as a rational number. Once we are assuming, then what will we do? We will do 6 plus root 2 can be written as like this. Yes or no? 6 plus root 2 equal to a upon b. Now bring this right side to left side, and this will be negative, and there will be what? 6, and there will be what? This is a positive, so we will take this side and we are getting negative 1 minus root 2. Now take LCM. LCM is the b. How many times it is going? B times it is going. So b we will be multiplied by this numerator. 6b will be there. Minus, not minus, there is a plus. So sorry, there is a what? Minus sign. There is a minus sign, and there is what? Minus sign. So we will get this one, and there is what? There is minus of 2. So from this equation we will conclude result that what we are getting, 6 plus root 2 is an rational, not irrational, it is a rational number. Observe, I am doing some correction in the last example and solving this one. Question number 3, third one. What is the question? We want to prove 6 plus root 2 is irrational. How we will solve? We are assuming this one as a what? Rational, a upon b. Now transposing, we are separating rational one side, so this one is the rational, so we will bring to the left. We are getting 6 minus a by b, and bring this one to right, so minus root of 2. In the left hand side I am taking LCM. B is a LCM. We are getting b times it is going, we will multiply by 6b minus how many times it is going? B times a will be there. So from this equation what we can say, left hand side is a rational and this one is what? Irrational. This one is irrational. So this equation is wrong. Once in the equation left should be equal to the right, but this is wrong. So our assumption will be what? So from equation 1, left hand side is rational and right hand side is irrational. So our assumption is wrong. Therefore 6 plus root 2, 6 plus root 2 is an irrational number, not rational. So it is an easy question. I solved there. Now I am taking question number 2. Observe, I am taking question number 2 of your exercise. Prove that 3 plus 2 root 5 is irrational. 3 plus 2 root 5 is an irrational. We want to prove this one. So for prove this one, we will assume let 3 plus 2 root 5 is rational. We are assuming first this one is the rational number, and rational is written in the form of p upon q. So 3 plus 2 root 5 can be written as a upon b, where a and b are integers. What? A and b are integers. Now take Now what we will be do? We will separate. So I am taking this rational number 2. A upon b is a rational, 3 is a rational. I am taking this one to the left side, 3 minus a upon b, and bring this one to the right side, minus 2 into root 5, minus 2 into root 5. So what we will be do? Now we want to divide this one. We want to divide by 2. So what we are getting? Once we divide by 2 this equation, then what we are getting? 3 by 2 minus a upon 2b, yes or no? Once we are dividing, then what we are getting? 3 by 2 minus a upon 2b, and this will be equal to what? Minus of root 5. And another way, what we can say, we can take LCM and we can solve this one also, but no necessary to solve this one. This is the rational, this is the rational, this is the rational, and addition and subtraction of the two rational number will be what? Rational. Addition and subtraction of the two rational number will be what? Rational. So this side we are having rational number, and this is the irrational. This is the irrational. So what we can say, are you getting or not? What question I am doing? Prove that 3 plus 2 root 5 is a irrational. So first I am assuming this is a rational, putting a upon b. Now I am separating. How I am separating this one? I am bring this right side to left side and bring this one to right side. Now there is 2 is the rational and root 5 is the irrational. I want only the irrational one side. So transfer this 2 to this side, and how we will do this one? This number will be divided both sides, both numbers, not both. This number will be divided by 3 and there. How we will do this one? How we are solving? Like this: 3 minus a upon b divided of 2. Then in the denominator we are having this one. So we will divide by 2. Then this 2 will be there and this 2 will be there. So I am writing directly there. So 3 by 2 is the rational. This one is the rational. Both will be the rational. So result will be what? Well, in the equation, one side we are having rational, other is irrational. Left hand side is not equal to right hand side. Our assumption is wrong. So we can say 3 plus 2 root 5 is not irrational. It is not rational. It is irrational. So this is the process for solving of this question. Now I am taking question number 3, first one. Question number 3, first one. What question I am taking? Question number 3, first one. Observe this one. Question number 3, first one. What is the question? 1 upon root 2. We already know 1 by root 2. Division of the rational and irrational is a irrational. But we want to prove. And how we will prove this one? Just do. How we will prove? So for proving this one, we will assume let 1 by root 2 is rational, then this number can be written as 1 by root 2 equal to a upon b, and where a and b are integers. Now separate root 2. Root 2 is a irrational, 1 is the rational. But for solving this one, first we will do rationalize of this one. How we will rationalize? 1 by root 2 will be multiplied and divided by root 2. This one equal to a upon b. Then this can be written as like this, a upon b. So this will be what? 2a upon b. Now this solution, a, b are integers. Integers into integers. Integers will be what? Rational. Ratio of integers, rational, and this is irrational. So what we can say? left hand side is not equal to right hand side, our assumption is wrong. 1 by root 2 is not rational, it is irrational. We proved this way. I hope you are getting this process. Now last question I am taking, and what is the last question? Observe. Last question I am taking there, and that question is, what is the question? Fourth one. Not fourth one, second one. This question is second one. 7 root 5. This is irrational. Why? Because multiplication product of the rational and irrational is a irrational. We know the operation of the real number. Clear? So solution will be what? Let 7 root 5 is rational. First I am assuming this one is a rational. Then this number can be written as like of this. Yes or no? Where A and B are integers. A and B are integers. Clear? So now solve this equation. Root 5 will be equal to A upon 7B. This ratio is, this is equation 1, this is the rational, and this one is irrational. So this equation cannot be equal, so we can say left hand side is not equal to right hand side. So our assumption is wrong. So 7 root 5 is not rational, it is irrational. So what we studied in this exercise, observe this one. In this exercise we are having three questions. In the first question we want to prove root of 5. What? In the first question we want to prove root of 5. So like this question, if we want to prove, then we are having same process I given in this class. First I started with root 2, then root 3, then I proved root 5. We are having same process. First we will assume rational, then prove. Clear? In the question number 2 and 3 we are having another process, and how we will solve? We will do this process and we can easily to understand and we can prove. So I hope you are getting this process easy. You revise these questions again and again, you will get more and more idea. That's all about this class. Thank you so much.